Okay, hello everyone and welcome back to Hope Coaching Institute Private Limited. So this is theory part of thermodynamics lecture number 3, and today we will be discussing about Joule-Thomson effect, which comes in thermodynamics, and it is really very important for those students who are preparing for IIT JEE or NEET. So let us try to understand what it means and what is its concept. So it is a phenomena of change of temperature produced when a gas is made to expand adiabatically from a region of high pressure to a region of extremely low pressure through a small jet is called Joule-Thomson effect. So it is a phenomena basically which describes the change in temperature that is produced when a gas is made to expand. So this is a case of expansion of a gas adiabatically. So it is well insulated also, so that no heat exchange occurs. So there will be no heat exchange from a region of high pressure to a region of extremely low pressure. So heat is getting so no heat is getting exchanged, and temperature change will be calculated when pressure is changing from high to lower level through a small jet, or you can also write throttle. Okay, so let us try to understand this concept with a diagram also. These are the conditions on the left side and right side of throttle. This is a system that we have considered, and it is perfectly insulated system. This whole system is perfectly insulated. No heat exchanges is taking place between the system and the surroundings. So throttle is something that is basically used in engines that regulates the speed or the pressure of the system. So here it is actually reducing the pressure. As you can see in the definition also, initially the pressure is high and then it becomes low. We can also look at the definition of and the mathematical formulation of Joule-Thomson effect or coefficient. It is symbolized as mu Jt. This is the symbol for Joule-Thomson effect or coefficient, and mu Jt is equal to del T by del P at constant H. Change in temperature by change in pressure at constant enthalpy. So as you know that enthalpy is a function of temperature for an ideal gas. So for an ideal gas, enthalpy changes with respect to temperature. Okay, and in this system, the enthalpy at the left hand side and enthalpy at the right hand side, let this be H1 and H2, and it is same. Since the system is perfectly insulated, the process is adiabatic. So H1 is equal to H2. So if there is no change in enthalpy, so there will be no change in temperature also for an ideal gas. So the del T factor will also be 0. Since del T factor will be 0, and as you can see the definition and formulation of mu Jt, so the numerator is all about del T at constant H. So mu Jt also becomes 0 for an ideal gas. This is a very important point to remember. Okay, so let me write it again, that mu Jt for an ideal gas, is equal to 0, since H1 and H2 is equal to are equal. H1 and H2 both are equal. Why? Because the system is perfectly insulated. It is an adiabatic experiment. Okay, now let us try to expand for this thing for real gases and for something liquid. So the formula was mu Jt equals del T by del P at constant H. So we have to calculate the change in temperature. So del T will be something like T2 minus T1, as I have drawn in the diagram also. After throttle, this is P2, T2, and before throttle it is P1 and T1. So let this be T2 minus T1, let this be P2 minus P1 at constant H. This is mu Jt. So what will be the value for T2 if I take? So T2 under calculation will give us T1 minus mu Jt of P1 minus P2. So why I have written this P1 minus P2 instead of P2 minus P1? This, first of all, should I tell this again, that this I have achieved by multiplying this thing on the left hand side, P2 minus P1 on left hand side. But P2 minus P1 has changed to P1 minus P2. And we have taken the negative sign also outside, because a throttle has been used in between and it reduces the speed or the pressure or the thrust. So since it reduces the pressure, so initially the pressure will be higher and afterwards it will be reduced. So that's why. So P1 is greater than P2. That's why we have done this thing. And T2 becomes T1 minus mu Jt of P1 minus P2. Is it okay? Now, according to the equation, one thing also can be seen and observed and concluded. As you can see in this equation, mu Jt equals T2 minus T1 by P2 minus P1. This also shows us that in the numerator part, it also shows us that T2 is greater than T1. T2 is also greater than T1, but T2 is greater than T1 when the denominator is P2 minus P1. That is the reciprocal inverse of what we are taking. So let me make it more theoretical. If mu Jt comes out to be negative, that is mu Jt is less than 0. Okay, are you getting me? If mu Jt is less than 0, then only T2 will be greater than T1. See, in this equation where I have taken P1 is greater than P2 and we are taking P1 minus P2, so answer will be positive. Okay, but if T2 becomes greater than T1, then mu Jt can come negative, and T2 greater than T1 means on the right side of the throttle the temperature value will be higher as compared to the left side of the throttle. So the final temperature will be greater, and if the final temperature is greater, it shows heating effect. The system will show, obviously it will show a heating effect if the final temperature will be greater. So if T2 is greater than T1, then heating of effect will be observed. Is it okay? On the contrary, if mu Jt is greater than 0, if mu Jt is greater than 0, then T2 will be less than T1. Mu Jt greater than 0 means mu Jt will be positive. So if mu Jt will be positive, then T2 will be less than T1. That means final temperature will be less than T1 comparatively, which will show cooling effect. Is it okay? And the thing which I wrote earlier, that mu Jt will be 0 for an ideal gas. That also should be remembered. And one more thing can be deduced from the equation. That equation was T2 equals T1 minus mu Jt, P1 minus P2. So if T2 becomes equal to T1, now how this thing can take place? Only if mu Jt comes out to be 0. So if mu Jt comes out to be 0, then also T1 will become equal to T2. So pressure change will take place till you use throttle in the system. So throttle will regulate the speed and pressure changes will be there. They can be positive or negative. But yes, since throttle that has been used reduces the pressure, so P1 will be greater than P2 and temperature changes will be calculated. So temperature changes can be higher also and they can be lower also. So if T2 is less, then final temperature is lesser, it will show cooling effect. And if T2 is higher, then final temperature is greater, it will show heating effect. So what are the things that we have to remember now for mu Jt? First of all, what we are checking? We are checking change in temperature. For ideal gas, this thing is not valid since mu Jt is 0 for an ideal gas. The change in temperature will be calculated for real gases or liquid using a porous plug or throttle or small jet or valve. These are the names that we use for it. Okay. And the change in temperature can be positive also and change in temperature can be negative also. So T2 greater than T1 and T2 less than T1. These two cases you have to remember. So I hope you have understood the topic of Joule-Thomson coefficient. So these three things are the main conclusions and observations which are very frequently asked in competitive exams. Thank you. Thanks for watching.